Hi, everybody. It's great to meet you here. It's a great pleasure to be here. I'm very excited to present you the Amazon Poly, so the service which got announced just today by Andy Jassy. That's a service that turns text into lifelike speech. So first, short introduction about me. My name is Rafał Kukliński. I'm leading Amazon text-to-speech team. I'm also leading the Amazon Development Center in Poland. I'm a software developer. I used to work on various heuristic and algorithmic solutions for solving the problems like flight planning systems, for image processing, for image analysis. And 6 years ago, more or less 6 years ago, I joined Amazon. And since I joined Amazon, I have a pleasure and honor to work on the text-to-speech systems. So I'm working on we are working on the various aspects of deep learning, signal processing, which we are applying to make computers to speak, basically. And today, during today's sessions, I would like to make you the short introduction to Amazon Poly. So first of all, what you can expect from this session. I will start with the short introduction. Why we build this service, what are the features of this service, what are the functionalities which we are exposing with Amazon Poly. Then I will give you a brief introduction about text-to-speech in general, so what's under the hood, how text-to-speech system works. I would like to also present you how to get started with Amazon Poly, obviously, so how you can make use of the service. I will tell you a few words about pricing of the service, obviously. We have also two awesome case studies which I would like to share with you to present you how our customers are using text-to-speech service. Last but not least, questions and answers. Let's get going. So, introduction to Amazon Poly. Why we build this service? So, one thing which is quite obvious nowadays is that speech becomes the ubiquitous element of applications nowadays. In all the solutions, we have more and more customers asking us about using the speech in their solutions and using speech as a standard element of the user interface. And obviously, our customers told us, and that's quite obvious, that as the text-to-speech and speech in general becomes the element of the user interface, the naturalness of the speech, of generated speech, becomes critical for the naturalness and the quality of the user interface we are providing to our customers. So one thing which we learned is obviously that quality really matters. Second point, which was really interesting for us throughout several years when we were offering text-to-speech, is that ways how customers are integrating text-to-speech in their applications varies a lot. So we have customers who are using text-to-speech and streaming directly from the cloud and directly from the service. We have customers who are using text-to-speech and needs to cache this speech before serving to customers for various infrastructural reasons. We have customers who wish to use speech and store it on their devices or on their solutions and then provide to customers, to end users. Last but not least, we have also situations when generated speech should be embedded in the final solution, like in the video or on the device, and then serve to end users. And with our text-to-speech system, we figured out that simply we have all the blocks and all the elements which allows us to address all those requirements of our customers. So, what is Amazon Poly? As I said, service which turns text into lifelike speech. We offer 47 lifelike voices across 24 languages. We have low latency of responses, which enables developers to build real-time solutions. That's because the text-to-speech service is a streaming service, so we are serving speech as soon as possible to the application. The final point, developers can store, replay, and distribute speech whenever they wish or whenever the application requires to do so. I mentioned the naturalness of the speech, so in fact, that's a quality of a speech. So let me give you a short, brief introduction about what does it mean, quality for the text-to-speech system. And that's not a trivial problem to describe this. So we measure quality of text-to-speech systems in three dimensions. First dimension is naturalness. And naturalness corresponds to how close generated speech is to the speech of real human being. Let me play an example.
Alice was beginning to get very tired of sitting by her sister on the bank, and of having nothing to do. Once or twice she had peeped into the book her sister was reading, but it had no pictures or conversations in it. And what is the use of a book, thought Alice, without pictures or conversations?
So as you can hear, Amazon Polly is able to generate very natural speech. And we have to measure that or to rate whether the speech is natural or not, we need to have a way to measure the subjective element, so subjectiveness of naturalness of a speech, because what does it mean that speech is natural? What we do, we simply mix the output of our text-to-speech system with samples generated or speech generated by a real human being. And in the blind test, we are asking a huge amount of people to rate the naturalness of the speech. And whenever there's rating of text-to-speech is close enough to real human being, we decide, yes, that's this voice, this particular text-to-speech system is capable to be released to end users. That's how we reach the naturalness of the voices. Second element of quality of text-to-speech system is accuracy of text processing. So when text is provided to text-to-speech system, it contains not just canonical words, not just standard words from lexicon of particular language, but also various text structures, like acronyms, abbreviations, homographs, so words which are written exactly the same but pronounced differently depending on the context. And users simply expect that text-to-speech system will be able to interpret those text structures correctly. Let me show you 3 examples. By the way, as far as I know, that's really the temperature in Las Vegas, so we have a weather forecast for free.
Today in Las Vegas, Nevada, it's 54 degrees Fahrenheit.
So you can see here that we have various elements which needs to be interpreted by text-to-speech system. NV, we need to understand that in this context it's Nevada. We need to understand that F in this context should be interpreted as Fahrenheit, and so on, so on. Another sample. Please notice that we have 2 instances of word live or live.
We live for the music, live from the Madison Square Garden.
So again, we need to understand the context of in the sentence to understand how we should interpret this set of characters, how it should be pronounced. This is definitely not a trivial problem. And accuracy of text processing is already an objective measurement. So we are able to scan through various texts and measure what percentage of or what ratio of text we are able to interpret correctly. Intelligibility is the third dimension to measure quality of generated speech. And intelligibility is about if, or we are checking if end users are able to comprehend information from the speech. Let me play you a sample.
Peter Piper picked a peck of pickled peppers.
Try to repeat that. I won't dare. So simply the measurement here is we are asking end users to just listen to the speech and being able to provide us what we just said. And whenever users are able to copy exactly what has been said by text-to-speech system, it means that they comprehend each particular word. So that's how we measure, and that's why we claim that the Polly provides the lifelike speech. I mentioned language portfolio, 24 languages, 47 voices. Here is the list of languages which we provide with Amazon Polly, which are available in Amazon Polly today. Those orange areas present areas of the world where particular languages are being spoken. So in other words, those are areas where you can serve your application or build your application for and voice it with Polly. Few words about features and functionalities which we provide with Polly. One element which I would like to mention is SSML. SSML is a speech synthesis markup language, W3C recommendation. SSML is here to enable developers to instrument text in a way, or instrument a text to point out how particular elements of the text should be interpreted, or whenever I have the special need and special request how this particular element of text should be interpreted. This case I particularly like because that's always a challenge for me. So whenever I'm approaching a hotel or whenever I'm checking in the hotel in the United States, I'm asked to spell out my last name, which is tricky because English is not my first language, and which is tricky because we are not used to that in Poland. So text-to-speech fortunately have a SSML which allows it to to make it simple.
My name is Kuklinski. It is spelled Kuklinski.
So here with the XML format, we are pointing out first that we would like all the letters in my last name, so Kuklinski, to be spelled out. And secondly, we are asking also text-to-speech to say it slowly, to slow down, simply to be able to make sure that the listener will be able to comprehend each particular letter. Second functionality or feature I would like to present to you are lexicons. So whenever you are reading application or building application with some words which are unusual, words which you would like to be interpreted in a specific way, you can use lexicon to customize pronunciation. So that's really my daughter's name, and the pronunciation, default pronunciation in English would be more or less like this.
My daughter's name is Kasia.
And that would be okay. The problem is that my daughter is Polish, and the right pronunciation in Polish of this particular name is Kaja, and that's what I would expect, and specifically my daughter would expect. So what you could do, you can enter and create an entry like this and say, whatever the spelling of word Kaja will be, whenever you will use all capital letters, just small letters, use this phonetic transcription. This one is here done in X-Sampa, so phonetic alphabet, which is also a standard. Use this particular pronunciation. And it means that every application on your account where you apply this rule,
My daughter's name is Kaya.
will behave like this. So how we made it happen, to how the text-to-speech works and makes it possible to give you this kind of result. So a bit of details, or some details of text-to-speech. Let's start with the goal. Goal for us is to produce natural, intelligible, accurate speech synthesis. Challenges, I mentioned a few of them already. First are homographs, so words pronounced differently. Here's another example of live. I live in Las Vegas. This presentation broadcasts live from Las Vegas. That's a specific example also of a kind of homography, but also a problem with the text processing. So please notice that ST, depending on the context, will be pronounced as street or saint. And again, you would expect the text-to-speech system would be clever enough to figure that out. Grapheme to phoneme conversion, so conversion from letters to sounds. That's another challenge. Please notice that we have three words which seems that they should rhyme from how they are written down, from the spelling. However, they are pronounced completely differently. Tough, dough, true, right? Pronunciation is completely different. Last but not least, in the language, you can expect foreign words, déjà vu, proper names like names of politicians, famous people, so on, slang. So also, you would expect the text-to-speech system would be able to handle that. So how we make it happen and how it works in text-to-speech systems to interpret text correctly. Let me show you what are the steps of speech synthesis system. So let's take a specific example. Let's take this text. Market grew by more than 20%. What we do in the text-to-speech system, we start with text processing, so with text interpretation. We are taking the text and changing every particular token, so every particular combination of letters, into its canonical form, so into word from a lexicon. Here, as you can see, we have already words. Once we have that, those are words which we figured out. Once we have that, we are changing it into phonetic transcription. So basically, we are performing so-called grapheme to phoneme conversion. And here, because of the fact that that's that's a difficult simply problem to solve, we are applying deep learning and machine learning mechanisms to be able to figure out what's the right pronunciation for a particular sequence of letters. And we are getting to phonetic transcriptions, which are sounds that we expect to pronounce. Once we will do this, we need to apply machine learning again, because now we need to figure out what should be the intonation of the sentence. So what's the desired, we call it prosody, what's the desired prosody contour that would be expected from real human being? When we will figure out that and figure out what's the prosody contour, we are using the inventory of speech to produce the final waveform. and I will cover it in a minute. The one thing which I would like you to remember is that we are gathering the speech from specific voice talent, which matches our personality. And for this voice talent, we are gathering lots of audio data that are able to cover all phenomena in the language. And simply here in this step, we are selecting units from this speech inventory, putting them all together and adapting to sound naturally. Last but not least, we need to make the prosody modification to make sure that what we selected from the speech inventory will match the intonation that is expected from real human being. And we can stream audio.
Market grew by more than 20%.
Here we are, easy as pie. Unit selection. I mentioned that we are selecting units from a speech inventory. This technique is called unit selection. It guarantees that we are able to produce high-quality speech. Unit selection is a conversion from the phonetic transcription, so from phonemes to waveform. Database of recorded audio is gathered from the single voice talent, which is, let's say, corresponds with the desired personality, and should cover particular combinations of speech sound or sounds which we expect in a particular language. Our unit, which we are selecting from the database and connecting with each other, is a diphone. And diphone is a half of one phoneme and half of another phoneme. We did it that way because simply we figured out, and we noticed during tests and during work on text-to-speech system, that concatenating units in the middle of the sound is simply less audible and less disruptive for end user than concatenating between phonemes. And that's why a diphone is our unit. We need to make sure that in our database we cover lots of various features for speech synthesis. So here's an example, is an allophonic variation. So we are not just covering every particular phoneme and combination of those phonemes. We also need to make sure that we have in our database phonemes which are next to the consonant, next to the vowel, first in the sentence, second in the, or first in the word, somewhere in the middle of the word. So we need to understand what's the context of the particular unit. Here is the perfect example. It's called allophonic variation. The thing is that PI, this connection of those two phonemes, sounds differently depending on the context. So here you have pin, spin, limping. And if you would use it between those words, we will use exactly the same diphones. It would sound simply unnatural. So we need to cover that as well. And we have hundreds of this kind of features that we need to cover, which makes selection of a speech inventory really a difficult problem. So let me get to that. To record our text-to-speech, we are using tons of texts. And those are books, news, web content, various texts which we are simply feeding to our automatic systems that are able to select those texts which match and are able to cover all phenomena in the language. And out of this, we are producing recording script, which we are recording with voice talent. And in this recording script, we are covering all the combination of diphones and significant features that are important for us, that we know that we will need in the text-to-speech system to produce speech. Here, how it works in practice. That's an example of a sentence. An apple a day keeps the doctor away. And what I will present are real sentences from our recording script, which we recorded with our voice talent. And simply the unit selection selected units from those sentences. So we have first sentence, an error occurred, and so on, so on. We are selecting n from this. Then we have another two sentences from which we figured out that we need units from those sentences to concatenate to make the connection from n to apple. Please notice that we have theoretically apple here, but we need this connection with the previous letter n as well, so with this combination, so we need also this coverage. And again. So all those units are taken from completely different sentences and then concatenated together to sound naturally. And output is, not yet.
An apple a day keeps the doctor away.
So as you can hear, you cannot hear any connections between units. So how to get started with Amazon Polly? That's pretty easy. All this technology is available to you through console.aws.amazon.com. So you just need to get started with the service. And I would like to also show you a few samples of how we are dealing in the console with particular texts. And for that, I need to switch the computer. So just please give me a second. So here we have the console. Oh, sorry.
Hi, my name is Joanna. I will read any text you type here.
Okay, so that was easy. Let's try something more sophisticated. So in the console, you can try particularly any text. So here we
I
have,
heard that Outlander is a good read, though I haven't read it yet.
so as you can notice, let me repeat that. As you can notice here, we have another example of the homography, so read and read differently depending on the context.
I heard that Outlander is a good read, though I haven't read it yet.
I mentioned previously that we have ST, the problem with, or problem, a challenge with dealing with homography between acronyms. So here is an example of one of
St.
those.
Mary's Church is on 226 St. Mary's Street.
So as you can notice, this ST, depending on the context, is pronounced differently, and we are able to handle that. Obviously, the challenges in the text and the amount of interpretation of the text that you can expect is completely, might be bigger. So let me play a sample. So that's a little
1
bit.
pint 8 ounces, 24 fluid ounces 710 milliliters.
So all those units need to be interpreted correctly. That's something that's what you would simply expect, because that's how human would behave. I mentioned also that in speech you can expect foreign words, you can expect proper names. I have an example of that as well. Here you have the various.
Love him or hate him, Gilles Arnaud continues to challenge the zeitgeist, leading the charge towards a new society in Nice, France.
So you have here proper name, Gilles Arnaud, which should be pronounced with the French pronunciation. You have zeitgeist, which is clearly a German word. You have Nice, which is a homograph because it can be also pronounced as nice, because that's a standard English word, and so on, so on. We can also expect words which are created, let's say, overnight. So language is changing constantly. Specifically, artists are very creative, which is not that surprising. So
Pink's latest album is The Truth About Love.
we all know that it should be pronounced pink, but computer needs to also have a kind of intelligence to be able to figure that out. Kesha is another example of that. We also, with the SSML, I would like to also show you a sample of the text and sample how we could use SSML. So here we have
Jesus Manuel Corona is a Mexican professional footballer who plays as a winger for Portuguese club Boa Vista.
and that's okay, because that's what a US English native speaker would expect, but obviously that's a Mexican footballer, so it's pronounced Jesus. And what we would expect is that we would apply for the US English voice Spanish pronunciations. What you can do, you can use SSML for that.
Jesus Manuel Corona is a Mexican professional footballer who plays as a winger for Portuguese club Boa Vista.
So here we are hinting that text-to-speech engine, please pronounce this part of the sentence with the Spanish pronunciation, and please pronounce this part of the sentence with a Portuguese pronunciation, and here we are. We are able to do that, obviously with US English accent, because that's an US English voice, but that's the pronunciation according to Spanish and Portuguese pronunciation rules. There are many samples of that, many examples like that, which you can try out in the console. Please do it, please sign up. What you can do from the console, obviously, you can switch voices, you can change the language and region for the text-to-speech. You also can store files in form of MP3 files, store the speech in form of MP3 files. I will switch back to presentation, because I also would like to show you how to make the integration in your program, in your application. That's pretty easy. As you can see, it requires just a few lines of code. And honestly, just this part, poly.synthesize speech, is a part which is really the request to poly service. You are just providing a text, specifying what output format you would expect, and specifying the voice which you would like to use to synthesize speech, and you are getting the stream of audio samples. And the next part of the program simply stores those audio samples in the form of MP3 file. Specifically, this code is in Python, but you can use all the SDKs, all the APIs, which are available for any other AWS service, obviously. Amazon Poly is cost-effective. So first of all, obviously, pay-as-you-go pricing model, which means that you are charged for the speech which you will, or for the amount of text which you will push to the service. And by amount of text, I mean amount of characters. So if you will push 10 characters to the service, you will be charged for 10 characters. If you will push 1 million characters, you will be charged for 1 million characters. And 1 million characters costs $4. That means that for $4, you are able to synthesize, and here I need to refer to my notes. So it costs you 66 cents, for example, to synthesize The Christmas Carol by Charles Dickens. It will cost you $3 to synthesize Two Towers from Tolkien. And if you would like to synthesize the average news article, it's a cost of 3 cents. So that's how those $4 for 1 million characters converts into costs for your application. We are also providing a free tier of 5 million characters per month for first year. And again, to try to build the imagination or build this perception of what does it mean, 5 million characters is the amount of characters which allows you to synthesize 1,600 email messages monthly. I'm not sure if you are getting that many emails. I hope not. You can synthesize 770 news articles, average news articles, again, monthly. It's also enough to synthesize 3 first parts of a Song of Ice and Fire. So the names are A Game of Thrones, A Clash of Kings, and Storm of Swords, if I remember correctly. So that's what does this mean to have 5 million characters of a free tier? Last but not least, you can store and reuse generated speech in your application if you need it, if your use case requires that. That's what I wanted to say about the service and provide you with the introduction to the Amazon Poly service. I would like also, and we would also would like to present you 2 case studies of how text-to-speech service can be used in application. And here we have the honor to invite guests on stage. Please welcome Severin Hacker, who is CTO of Duolingo, and would present you how Duolingo is using text-to-speech. Severin?
Hey. Hello, everybody. My name is Severin Hacker. Before you ask, this is my real last name. It's Hacker. I was born like that. Before we start, who actually has heard of Duolingo? Raise your hand. All right, that makes it a bit easier. So for those of you who don't know, Duolingo is a free language learning app. It's in fact the most downloaded language learning app in the world. It's also the most downloaded education app in the world in both the Apple App Store as well as Google Play. Here's some screenshots. This on the left is the skill tree. You can basically proceed through that skill tree. There's like challenges like the ones in the center. And when you finish a lesson, you get that screen. It's very gamified. And it's also, it actually works. So we did a study in 2012 that showed that 34 hours of Duolingo are equivalent to 1 college semester of Spanish. So all those hours that you spend on Duolingo, they're not wasted. You will actually learn the language. Now, what I want to demo today is actually the bots. Some of you may have seen this already. This is actually live in the iOS app. So let's see. Got it. All right. So this is your usual Duolingo. And in the newest version of the iOS app, you will have this tab here. which opens the chatbots. So the idea here is that you learn a language through conversation with an AI bot. Okay, I'm going to present you here this one here, which is in Spanish and which uses the Amazon Polly voice. Okay, so he asked me, for those of you who don't know Spanish, he asked me, do I want a table? So let's say, okay, see.
¿Le gusta esta mesa?
Now he asked me, do I like this table? And what should I reply? All right, I say, okay.
Esta mesa es terrible. Lo siento mucho. ¿Y esta mesa?
All right, that one looks much better. So I say, and obviously, if I don't know how to reply, let me show you this. I can use this button here, help me reply, and I can say, okay, muy, bueno.
Bien, tome asiento. ¿Qué quiere tomar?
All right, say, I want a beer.
Solo tenemos agua, té, chocolate caliente y café. ¿Qué quiere tomar?
All right, so he doesn't have beer, so I'll, of course, go for the hot chocolate.
Aquí tiene.
All right, you get the idea.
¿Y
So
de comer? ¿Quiere un sándwich o una ensalada?
I'll go back to the presentation. So as you can see, voice really matters for Duolingo. If you want to learn a language, you want to learn the spoken language. That's really crucial. Obviously, the pronunciation really matters. If the pronunciation is bad, you're going to learn the wrong pronunciation, and then people won't understand when you actually go to the country. Now, people always ask us, like, why did you actually choose TTS and not like record, human voices like yourself and have those samples? And the reason is it allows us to go faster. So it allows us to generate new content and then just run it through TTS and put it into the app really fast instead of having to hire a voice talent and record it and put it online and all that. So it allows us to go faster. And we actually found that the TTS provided by Amazon, Polly, are as good as natural human speech for the purpose of language learning. So you may wonder, how good is Amazon Polly actually? And we put it to the test. We have all these millions of users, and what we do at Duolingo is we do A/B tests. So what we do is we have two voices, voice A and voice B, and we give each voice to 50% of our users. So in each bucket, there's tens of millions of users, and then we measure learning and engagement, right, of those two buckets. And you can see here in this case, the blue voice is much better. It has higher learning and higher engagement. So we would pick the blue voice, and that would be then the Duolingo voice for that language. Now, all the results I'm going to present here are actually statistically significant with a p-value of 0.05. If you don't know what that means, it doesn't matter. So first one here, this is English. So this is the new voice.
Should we continue the argument on Tuesday?
And this was
Should we continue the argument on Tuesday?
So I hope you can hear the difference, actually. And as one of our users said, the new voice is a huge improvement. I really like it. The old one was terrible at times. And here's Portuguese.
Como ela se sentiu ontem?
This is the new one. The old one.
Como ela se sentiu ontem?
Yeah, so this one is so obvious. Even if you don't know the language, it sounds just better. So this user said, I started getting a new voice for my Portuguese lessons. It's so much better than the previous one. In terms of comprehension, it's miles better. And the last one here in German. This is Hans.
hat sie gefragt.
This is new voice, and this is our old
hat
voice.
sie gefragt.
And what's actually funny is like one of our users said, the German male TTS is music to my ears. This is the first time I hear a comment like this about German. So, and these are all the voices we use in Duolingo, pretty much all of them actually. And just the last slide here is I'm going to quickly talk about how we implemented the infrastructure for this TTS in Duolingo. So it's basically a microservice, and it's hosted on Amazon Beanstalk. Now, all the voice in Duolingo is pre-generated, so we don't use the real-time thing. It's all pre-generated. And when we have a new sentence, we basically make a request to this web server in Beanstalk. And that web server creates a message that's put on this Amazon SQS queue. It gets picked up by a worker. The actual worker creates and updates the metadata in a DynamoDB table, generates the TTS through Amazon Poly or a third-party TTS. Once it has the file, it puts it up into an S3 bucket. And from there, it gets globally distributed through Amazon CloudFront. And the actual device gets the file from CloudFront. And that was it.
Cool. Thank you very much. Thanks, Severin. It's really great to hear that our German voices are music to someone's ears. That's really awesome. I would like to also invite Stacy, who is marketing manager for Go Animate. Stacy will show us another awesome example of how text-to-speech might be used for the text-to-speech for applications.
Yep. I'm going to go ahead and get the audio and visual for the demo. Oh, is that good for 3? No, I don't want to switch yet. I want to stay here first. Okay. Okay. So I am Stacy Adams, and I'm the head of marketing for Go Animate. And Go Animate is a do-it-yourself animated video creation platform. And something interesting about me, actually, is from 2007 to 2010, I actually worked in the opposite of text-to-speech. I worked in the voice-to-text sector for a couple of companies, one of which was actually acquired by Amazon, which was quite interesting that I'm here today talking about text-to-speech. So what is Go Animate? So like I said, we're a do-it-yourself video creation platform. We are less resource intensive than live action or professional video. So we're a SaaS-based platform, web-based subscription service that allows you to go in and create characters, move things around. The animations are built in. I'll show you a little bit of a demo towards the end here. And who uses Go Animate? So our primary audience are the training and e-learning professionals, so people creating corporate training for large companies, HR professionals creating onboarding, a lot of lessons where video enhances engagement and audience participation versus just using static text or PDF or some of those canned videos I'm sure we've all seen when going through HR or training for our various businesses. So we also support marketers, so marketing folks who are doing animated explainer videos, social media videos, doing videos for Facebook, for Twitter. You can export a Go Animate video as an animated GIF for use in email marketing. So lots of practical application for the platform. We also have a product called Go Animate for Schools. And the schools product we sell at a reduced rate to K through 12 educators so that their students can learn and use animated video in their education. So what are the use cases for text-to-speech with a platform like Go Animate? So we talked about training, we talked a bit about HR. One of the things that these folks use Go Animate for and use the text-to-speech function for is when they have a training video that needs to be produced in multiple languages. So you're a global international company, you have a short training video that you need to distribute. You don't have enough resources to create this video 20 times over in 20 different languages, so you're going to use text-to-speech to do that that video. And then more so on the marketing side, somewhat in the HR and training, we see it a little bit. But when you need to do pre-production work on a video, so you're spending a lot of time and resources on creating something, you've storyboarded it, you've got your script, it's very nice in Go Animate to be able to use Amazon Polly and the text-to-speech function to actually see what that voice is going to sound like, the timing, how the scenes are going to work, what it sounds like with music, with a music track behind it, before you actually spend the budget and time to record a professional voiceover. So then, like I mentioned, in the K through 12 education space, a lot of the students who use Go Animate use the text-to-speech functionality. It's a lot easier for them to manage. Sometimes they're not really comfortable using their own voice, and they definitely don't have access to professional voiceover artists to create their material. So I'm going to give you some video examples. This is a video that was done using Amazon Polly's one of the French voices by one of Go Animate's customers.
Le sujet du jour est la musique. Notre budget est déjà très serré. Comment faire?
Mais peut-on trouver de la musique gratuite?
Vous trouverez de la musique gratuite sur plusieurs sites.
So we'll go on to the next one, and I've got another example of this is text-to-speech in a school environment for Go Animate for Schools. And this was a campaign that these kids actually won an award from their school for this video on cyberbullying.
We have been brought here to talk about cyberbullying.
Together, if today does anything, cyberbullying should be known, and people realize that cyberbullies are not nice and they can hurt people's feelings.
Some things people should know about cyberbullying is it happens online.
It could be on a video game, it can be done over email, or a group chat.
Cyberbullying can happen to anyone, whether you are 12 or 100.
So those are just a couple of examples. So now I'm going to switch over to my laptop here, and let's see, MI3. Okay, so this is the Go Animate platform. I apologize sometimes with internet, it can be a little bit slow, but this is what people see when they first open and start a video. So I'm going to add a scene through the tray over here. I'm going to remove elements of this scene that I don't want, here and here. I'm going to switch this character out to someone who looks a little bit more like me when my hair's not straight. And I'm going to make this character talk. So if I go back here, there's a dialogue button. So this is where you add you can record with the mic, you can upload a voice file you already have, but I'm going to click the text-to-speech button. And now I'm going to choose a female voice. And as you can see, we've got different languages here. And then I'm going to choose Sally's voice. I'm going to generate that voice.
Hi, I'm Stacy Adams, and I'm the head of marketing for Go Animate.
So that sounds great. So I'm going to add the voice. So as you can see down here, the voice has been laid along this track. And my character is actually lip syncing to that text-to-speech voice. So I'm going to preview that. This is where it might take a minute.
Hi, I'm Stacy Adams, and I'm the head of marketing for Go Animate.
So pardon the flashing, but that gives you an idea of how incredibly easy it is to apply a voice to a character in Go Animate. But Amazon Polly really supports our customers, our users in doing so in an easy, efficient manner that very much replicates human speech. So thank you.
Thank you, Stacy.
Okay.
Thank you very much. Thank you, Stacy. Thanks, Severin, for those great examples of how text-to-speech might be used in your applications. There are many other ideas of applying speech for your applications, and probably won't be able to even imagine all those use cases. So thank you very much for joining this presentation. I hope you like it. I hope that you will find text-to-speech as an interesting solution for your application. And also looking forward for questions if you have any. Thank you.